All right, so what is technical debt? So technical debt is basically when the code becomes harder and harder to understand and harder to change. So the metaphor of debt is basically you take shortcuts on your quality, on your practices, your software engineering practices, and you have to pay it back later on in with a lot of interest, right? So say I'm in a hurry. I don't want to. I'm in a hurry with my life. I don't want to save. I want to be able to travel to Europe, or I want to have a nice car. Um, I'll borrow a lot of money and enjoy myself for a while, right? But then I have to pay all of that debt with compounded interest. Maybe initially I have a very fast lifestyle, and later on my lifestyle becomes very slow. All I can afford is instant noodles. Technical debt is just basically the accumulation of complexity. So imagine you have a very simple machine that only has two switches, and each switch only has two settings, maybe. So the settings could be on, off, on, off, on. So how many scenarios do you have there? How many ways can these two switches interact with each other? How many ways can can things go wrong? How many scenarios do you need to inspect and test to make sure everything's working? So in this case, it's only 4 scenarios, right? Um, so let's make a slightly simpler machine. So this machine only has 3 switches, and each switch only has 3 settings. So how many scenarios do you think this machine has? How many interactions do you think these 3 components, how many ways can they interact with each other, right? So it jumps quickly to 27, right? So 27 ways these things can go wrong, 27 scenarios that you have to test to check that everything's working and that there's no bugs. So now we modify the machine slightly. Now we have a machine with 5 components, and each component can be set in 5 different ways. So how many interactions do you think these 5 components have? How many ways do you need to check to make sure nothing went wrong? So it quickly jumps to 3,125. That is called, in software engineering, that is called combinatorial explosion. Every time you add a component to software, that component, that new element, could possibly interact with everything else that's already there. Every new component has the potential to increase the complexity of software by a huge amount, right? So exponential growth of complexity. So if you imagine the capacity of a software development team to be like a pipe, the requirements go in on one side, and out goes the features developed on the other side. So initially, when a software development team is starting, their entire capacity can be dedicated into turning requirements into features. Then it's normal that over some time, there are some bugs that appear. So not all of the team's capacity can be now dedicated to turning requirements into features, because they now have to fix bugs. But when there's an accumulation of technical debt, now a large portion of the capacity of the team is now consumed just by the team having to deal with code that's difficult to understand. They have to take a long time to read the code. And when they make changes to the code, it's very fragile. It takes them a long time to make changes, and then they end up breaking more things, which leads to even more bug fixing. So even less of the team's capacity is able to turn requirements into features. So eventually, we get to this point. There's so much technical debt that most people in the development team don't understand the code. It's very difficult to understand. And when they make changes, it often introduces more bugs. So very little of the team's capacity can now be used to turn requirements into features. So how quickly does this happen? This is the chart from an actual software development team. So the red line are tickets being opened, tasks being created, and the green line are tasks being closed. So initially, in the first 2 weeks, the software development team is very productive. Every time a task is opened, they're able to do it right away. It's closed within the same day. But if you notice, after the first 2 weeks, the gap between opening and closing of tasks gets wider and wider, right? So that's the accumulation of technical debt. So this is just over 4 months. So in 4 months, the technical debt has accumulated so much that it takes a very long time for new tasks to be implemented. So what does this mean for the business? So most businesses think that the cost of building software is just the initial software development and maybe a little bit on the introduction of the software. So they think, okay, we'll build the software and then there's going to be some changes after we introduce it, but that's fine. After that, we don't have to spend anymore. But actually, studies show that 80% or more of the cost of software happens after the software is released, after it gets in the hands of users. So users will always want new features. There's going to be changing market demand, changing market preferences. There will be competition, and also there's changes in government regulation. I remember we were at the end of one banking project we were already about to deploy when the anti-money laundering authority of the government said, hey, you have to implement this additional feature. So the bank couldn't tell the government, hey, we're already about to release. Can you wait a few more months or sometime next year? No, they wouldn't be able to do their business unless they comply with regulation. So we had to, because of the change in regulation, we had to add additional features to the software. And of course, government regulation is ever changing and software has to keep up with those changes. So it gets to the point that the cost of software development gets out of control. So as we saw before, complexity is exponential or geometric in its growth, not managed properly. At some point, in many cases, people still want to buy the software. People still there's still a very active customer base to the software. The cost of maintaining the software already exceeds the revenue, so the company is actually losing money from the software. Companies need standards and processes, and their engineers need to be trained so that the complexity, while it still grows, can be managed. So that if we apply proper engineering practices, I like to call these technical investments as opposed to technical debt. So it takes a little bit more effort, a little bit more education, a little bit more time defining those processes and standards and setting up the environment to make those processes and standards easy to implement. But if we do, the growth of complexity is more manageable. The company, the products can still be profitable because the cost of maintaining the software is managed.